we're going to discuss about Haskell, its advantages, the community and ecosystem. And the idea is for everyone to get introduced to the language, CTOs, engineering managers, to see whether it's something they could pick up with their teams, and also for developers to try to understand a bit more and see if it's something worth learning. Just a quick intro for those of you that are new here. Adeva is a remote network of tech professionals. Our goal is to enable work without boundaries. And these events are kind of part of that mission, where we enable everyone across the world to learn from leading experts like Andres today, and learn without boundaries. We have Slido as for every event. Someone will share the link with you in the comments so that you can ask a question there. And then at the end of the discussion, we will go through all of the questions on Slido, try to answer as many as possible so that we can cover everything you're curious about. And now, without further ado, Andres, welcome, and thank you for accepting our invite.
Thank you very much for having me here.
It's a pleasure. Let's start with a quick introduction. Just share with people who you are, what's your experience with Haskell, and how you can help us learn what we want to learn today.
Yes, my journey to Haskell began quite some time ago. I was an undergraduate student at the University of Constance, and I was studying mathematics. And if you study mathematics in Germany, you have to pick a minor subject. And I didn't actually originally want to take computer science, but I was interested in computers and interested in programming, but I actually wanted to take philosophy. But that turned out to be very difficult for organizational reasoning. All the courses were conflicting with each other, and sort of more in order to do something useful with my time, because I couldn't take the philosophy courses that I actually wanted to take. I started looking at computer science courses. And then I was very fortunate to meet a PhD student at the time, Thorsten Grust, who was a PhD student at the University of Constance. And he was very enthusiastic about functional programming. And he taught a course in my second or third year, I don't quite remember, about declarative programming, Prolog and standard ML at the time. And that really convinced me. I mean, before that, I had only ever seen sort of classic imperative programming languages. I mean, I have been programming in C and Pascal and C and BASIC and in various different programming languages, but I'd never seen anything like standard ML, which was a functional programming language, not unlike Haskell. And so I got interested more and more. And I started talking to him and said, I want to learn more about this. What should I be looking at? And then he said, well, I'm actually looking at Haskell right now. And Haskell is yet another language. And I think it's even more interesting. That's what he said. And so I started looking at it as well. And I also was very enthusiastic about it. I just thought it's a very nice language, certainly from a mathematical perspective. It's much closer to mathematics than typical programming languages are, and also just a completely different style of programming that I hadn't seen before. And I found it challenging and interesting, and therefore I learned more and more about it. And we created a little reading circle at the university at that time to read papers about functional programming and so on. And then at some point, I decided that I actually want to continue in that direction, and I want to do a PhD specifically about this. So I went to Utrecht University after I finished my undergraduate degree to the Netherlands, and I spent 4 or 5 years there doing research in functional programming and Haskell specifically, and that's really the time when Haskell not just became a language I was very interested in, but the language I was primarily programming in, and that was from 2000 to 2004. And then I pursued an academic career for a while. So I did a postdoc. I became a lecturer. I was a postdoc at Bonn University in Germany, but I returned eventually as a lecturer to Utrecht University. And then for partially private reasons, but also because the opportunity came up something like slightly more than 10 years ago, in 2010. I got the opportunity to join WellTyped. WellTyped was like a Haskell consultancy company that was had been set up in 2008, I think, by like 3 people who were like interested in having a company that offers like specific services around the Haskell programming language to commercial clients who are interested in it. And yeah, and they were seeking to expand, and I was like, yeah, for private reasons seeking to change like countries and jobs, and that was a good opportunity. So I joined WellTyped at that time, and I've never been really looking back. I mean, originally I missed academia quite a bit because, in particular, because I really like teaching and I like interacting with students, and but over time, I discovered that I can do all these things at WellTyped as well. It's sort of a remote company. We have clients from all over the world, and we do teaching as well. We do not just do software development, and it's been a really fun journey to these last 10 years, like working at WellTyped.
Yeah. That's great. And it's great that you managed to combine both of your passions at the end.
Yeah.
Let's go through a quick overview of Haskell as a language. Like, is it too specific? Is it more, general purpose language? What are its advantages? Essentially, what should people know if they're considering using it?
Right. So Haskell is a general purpose programming language. It's not a language that you that is only applicable to a particular domain. It's a compiled language that generates native code, so you can execute your binaries. But in terms of how it looks and feels, it depends a little bit on what other programming languages you know. It may look completely alien at first because, I mean, if you're familiar with sort of classic imperative programming or object-oriented programming languages like Java or C, then Haskell will feel very strange. So Haskell is like in the wider sense, it's a part of the family of functional programming languages. So other functional programming languages that are relatively similar to Haskell are languages like standard ML, which I already mentioned, but that's also rather exotic these days. More widely known are languages like Scala or F#, and possibly Erlang. These are all functional programming languages that are also being used. And I would say the core feature of a functional programming language is that you can abstract over functions. So that basically means that whenever you have a piece of code, just like you can say, like, there is an integer parameter that it varies over, so I'm going to pass an integer to it. You can also say there is a function parameter that this piece of code has, and so you pass a function to it. And functions are just first-class entities in these languages, that there is no conceptual overhead or no syntactic overhead involved in passing functions around and applying them. I mean, I know, for example, that if you look at C, in C, you can have a concept called function pointers, and using function pointers, you can also parameterize pieces of code over functions. But by means of being function pointers, they're sort of syntactically slightly more verbose to use, and you have to be careful. And so you don't usually do that, right? Whereas in a functional programming language, this is really sort of front and center, and one of the main features.
Sorry
the other
for interrupting
that,
here. Just one follow-up on
yeah.
the functional. In terms of functionality, like, when would you use a functional language over an object-oriented language, for example? In terms of what problem you want to solve?
I think it's not so much about like when would you use the one over the other. I think the big advantage that you get from being able to parameterize over functions is really that you get, with relatively simple means, like basically just like making functions first class and parameterizing over functions, you get a lot of abstraction power that you otherwise do not have. And that is just if you look at sort of general programming principles, and one of them is sort of you do not repeat yourself, right? And so you don't want to like write the same piece of code over and over again. That is something that you usually try to avoid. So how do you do that? I mean, typically you may, like if you're a brilliant person, perhaps design a program with all its abstractions built in upfront. But what is sort of the more typical evolution is that you discover that when you like write code, that you're repeating yourself up to a certain extent. You discover that you've been writing fragments of code that look similar to each other, and now you can basically play some sort of puzzle game with your language. You can say, like, can I identify the things that are the same everywhere? Can I identify the things that change? And can I just abstract over the things that change, make them parameters, and then I have my building blocks. But now the point is that it's very typical that within the things that change, like within the code fragments that change, you have again subfragments that are the same. Like, so that you have an interleaving between things that are varying and things that are static. And that is exactly where abstraction over functions arises, because like this flexible thing is sort of applied to stuff that comes from the function itself, from the repeating piece of code, from the pattern. And so basically what abstraction over function gives you is that you don't have to worry. Whenever you have any two pieces of program code that look similar, you know that you can always abstract over them. You can always find like a function that expresses this pattern clearly and concisely, and that is just like an immense advantage of this general feature. And that is one of the reasons why other programming languages these days that aren't even classically functional programming languages are also increasingly allowing you to abstract over functions. So in a way, most modern programming languages are actually hybrid languages that allow you to do these kinds of things as well. So in a way that feature of Haskell is not yet what sets it apart, but it is certainly one of the languages that started with this, and like one of the first languages that had this, and it is a language that embraces it fully. So it's not just sort of an afterthought, but it is a core design principle of the language.
Right.
Should I just go on with sort of
Yes.
Haskell features and advantages, or?
Yeah, go ahead.
Yeah, okay. So another important aspect, I would say, of Haskell is that it's a typed language, a statically typed language. And sort of historically, now perhaps in the really modern world, this is no longer quite so obvious, but historically, statically typed languages had a really bad reputation for a while. So like static typing was associated with languages such as C and Pascal and also Java. And it was like always like being seen as sort of a little bit baroque and noisy and unwieldy, and the type system isn't very powerful, but at the same time it gets into the way of code reuse. And one of the cool features that Haskell popularized and is now also integrated into many other languages is that it has a very strong form of type inference. And so that means that you do get all the benefits of static typing, namely that the compiler checks your program and it complains if you made an obvious mistake. But you don't always have to write out all the types. And basically, you only give type signatures for top-level functions where it's useful, because like top-level functions usually make up a part of the interface of your program, and there you want to be clear about what the types of your interface are. But whenever it comes to anything local and any local declarations or helper functions or things that you temporarily define, you don't have to mention types at all. The compiler will just track it for you, will figure out that you use everything consistently, and complain if you make assumptions that are not compatible with each other. And so it's difficult to explain without showing examples just how powerful the choices of Haskell are, because it's sort of a form of type inference that goes far beyond what most other languages have to offer. So so one aspect where type systems always collide with programming to some extent is, as I mentioned, is sort of code reuse. Like if you like go to classical programming languages, they didn't have any form of polymorphism. So you, like in the original versions of Pascal, you would have had to write a different sorting algorithm for integers than for floating point numbers, for example. But these days we know that sort of like the only important thing for a sorting function is having an ordering. So you can abstract over all the things that have an ordering. And Haskell discovers these sort of things automatically as well. So basically, when you mention an ordering function and nothing else, it will automatically detect that the only thing that you're assuming about the type that you're working with is that it has a comparison. And you can still apply your function to anything that has a comparison operator. So it's a very flexible compromise between static typing, having all the static guarantees, but not getting in the way by doing all this inference for you. And Haskell is having an amazingly powerful type system. So also for designing your domains, if you want to like model particular domains and express like how do the objects or the entities that you're talking about, how do they look like, which shapes can they have, which states should be representable, which kind of side conditions should always be fulfilled. Haskell allows you to be quite precise about this, and thereby to rule out many error states that your program should never get into, just by means of like the type system already, and basically make illegal states unrepresentable in your type system. And so that is really something that I think sets it apart from quite a few other languages. I mean, again, like I think F# and Scala are like, for example, as at a comparable level with respect to type system features, but Haskell perhaps goes a little bit beyond even these. And if you give me the time, there, like I would say, like the final thing that sets it apart from nearly everything else is that Haskell is a language that embraces like the Haskellers themselves are calling it purity, but I think that's perhaps a little bit too bold. I like to call it explicit effects. So the idea of that is that you do track in the type system whether a piece of program code has side effects or not. And with side effects, I mean anything from like disk I/O, network, random number generation, accessing the system time, even concurrency. All these are side effects that are typically not expressed in the type system of a language at all. So typically, if in a normal classic programming language, if you have a function that goes from integer to integer, then you don't know. Like if you call it twice with the same integer, you don't know whether you get the same result back, right? Because it could access some global variable, or it could read a file from disk and let that influence the result. In Haskell, if you have a function of type integer to integer, you know it is like that's where the term purity comes from. You know it's a pure function. You know it's deterministic. It will always result in the same thing. And if you want to have side effects, then it will have a different type. It will have type int to IO integer. And so you can by looking at the types, you can distinguish a piece of code that has side effects from a piece of code that is side effect free. And that at first seems just like a restriction, but amazingly, it is that because you can identify the parts of the program that are free from side effects, that is really what buys you a lot, right? Because you can structure your code in such a way that the side effects become isolated to relatively small parts of your code. And that is something that may seem unlikely, because people think that everything is sort of interleaved with side effects. But remember what I said in the beginning about abstraction possibilities. You can pull nearly everything apart, and even in a large system, you can usually identify lots of code that is essentially a pure function. And pure functions are very well behaved and very easy to test and very easy to reason about. And that is really something that that helps you a lot in day-to-day programming, because then you are much less afraid of refactoring your code or running your code in an unfamiliar environment. And having this explicit grasp of side effects is in my opinion, probably the most important feature that sets Haskell apart from other languages. It's not the only language anymore that has this, but I would say by far the most other languages that have this are directly inspired by Haskell. Actually, PureScript or Elm or Agda are languages that are inspired by Haskell and have like copied these kinds of features.
Yeah, that's very interesting. I can imagine how much time it would save, because all of the time bugs are coming up from things that are not well isolated, right?
Yes, and just to give an example, like if you think that say a web server or something is something that is deeply stateful, right? But in a way it isn't, because I mean it reacts to requests that come in via the network. Okay, so that is all side effects, but the requests are of, let's say, a number of different shapes. So you can describe that using a Haskell data type. You can say I have a data type that allows that it represents all the different forms of requests that can come into your program. And then depending on these requests, you may need some extra state. You may need some like access to the database or something like that. But you can describe that as an extra input to your function that basically is sort of the extra contextual information that you need in order to process the request in addition to the request. So you have this request and the context as an input, and then you have a response as an output. And the response, there are probably only a limited number of different shapes of responses, which you can describe as a Haskell data type. So in a way, the core functionality of such a web server can be described as more or less a pure function. And then around that, you can write code that like actually like listens to the network and deserializes the incoming request and produces a value of this Haskell data type, and vice versa, that takes the response and serializes again and sends it back over the network. But that's sort of a different layer, and you can isolate the core functionality of your web service from the whole networking layer, which means that you can easily run it in a different environment or test it out in an environment which doesn't involve a network at all. And it's just that the language encourages you to structure your programs in this way. Right. Of course, you can do it in other languages as well, but you typically don't, because if the type system,
yeah, so it's just going to say that like solid and everything.
Yeah, exactly.
The principles of good programming, but Haskell just makes you do it. Yeah, that's great. Let's talk a bit about the history. So it was created around 30 years ago, right?
Yeah, so in the beginning of the 90s, yes. So that, yeah. So
and at first it was.
Yeah, go ahead. Sorry.
At first it was just for the scientific community. You mentioned it's mathematical language. I'm guessing mathematics community. So how did it go from that to what it is now, and what were the first applications of the language in the industry?
Yes. Okay. So yeah. I mean, Haskell was originally designed by programming language researchers who were interested in functional programming. So so languages such as, for example, again, standard ML, they were around at the time. And then sort of a new fashionable feature came up in the scientific community at the time, which is also a peculiarity of Haskell, but one that I actually haven't mentioned yet, which is called lazy evaluation. The idea of lazy evaluation is that like in a normal programming language, if you call a function on a number of arguments, then basically all programming languages that are out there will first evaluate the arguments. And once they have evaluated the arguments, they will enter the function and execute the code of the function with these evaluated arguments. The idea of lazy evaluation is that you don't, like if you have a function call, you don't evaluate the arguments first, you leave them unevaluated, you just enter the function and see whether the function even needs these arguments and where it needs them. And only at the point where something is actually needed, it is evaluated just as far as it is needed in order to make progress in your program. And that was very fashionable at the time. And but there weren't any programming languages essentially. So that was a big new idea, but there weren't yet any programming languages. So people wanted to develop a functional programming language that had these features. And so different universities were designing their own toy languages that were essentially variations on existing themes. And there were like a couple of languages around at the time that were basically maintained by individual universities. And then people quickly discovered that, and that's actually interesting because these kinds of efforts usually fail, but in this case it hasn't. They discovered that this is not a recipe for success if everybody has their own little language and nobody has common ground, essentially. So they decided to form a committee and agree on sort of the best features of all these languages and bring them together and design a common lazy functional programming language. And that is where Haskell evolved from. That process happened roughly from, I think, 1989 to 1999, so in that decade, and actually culminated in the release of Haskell 98, which for a long time was sort of the standard version of the language that has been used and is still at its core very similar to the Haskell that is being used these days. And I wouldn't say that it was never on the minds of the original designers that it could be used for anything real. I mean, so it was not like designed to solve a specific problem. It was designed by programming language researchers and programming language designers, and obviously they're all happy if their stuff gets used in the real world. I mean, it's very rare that a researcher would say, I'm designing a new language, but I don't want it to be used. I mean, it's but it was more like a distant dream. And in fact, there is also this often misunderstood slogan in the Haskell language that came about at around this time, which was avoid success at all costs. And that's often misinterpreted to mean that people really didn't want Haskell to have success. But what it actually was supposed to mean was that they didn't want to sacrifice any ideals in order to obtain success. So obviously they were still interested in people using it and people using it for like real world stuff and industry use. But at the same time, they wanted to develop clean solutions for everything and not get sort of the goal of a quick success into the way of finding proper solutions for the design problems.
Right.
And I think as a result of that, it probably took quite some time. I mean, Haskell did so many things differently than other languages that really a lot of stuff was in the way of practical use at first. There were hardly any libraries, there were hardly any established design patterns for how to write code efficiently. There was no efficient compiler, although that was very, very quickly fixed. I mean, there were good compilers relatively soon. But there were lots of things like also around the tooling, and it was all from an academic background, right? There was no commercial backer. So and nothing was optimized for easy adoption or quick successes, and so there were lots of things that were needed in order to make it more viable for a commercial success. So I think sort of the big turning points were that like in the early years when I also used Haskell, there was no packaging system essentially. So people were sending code around by email and say like, look what I've written, and then other people were using parts of that code by copy pasting that into their own program or taking a module and reusing that in their own program. And so I am now unfortunately not remembering exactly when that was, but I think probably in the early 2000s, or around 2005 perhaps. There was a Haskell package manager called Cabal being developed, and a Haskell package repository called Hackage, and these are still in use. and they like really made the ecosystem explode, because all of a sudden everybody could exchange things and reuse each other's things, and that was a big step forward. And then another major turning point was sort of that a couple of people got together and wrote an O'Reilly book called Real World Haskell. And that was a while after Hackett and Cabal came about. But they really sort of like popularized common idioms and libraries that were out there, and focusing for a change not on like how to solve some theoretical problem or some neat algorithm, but how to do like real world things, how to access databases, how to put graphics on the screen, how to do networking, and so on. And that was an immensely successful book that I think made a huge difference as well. And then I think it's just time, right? I mean, also like the world itself has changed. I think in if you go 20 years back, it was still very common for programs to be written in a single language, or for companies to be essentially single programming language companies, and perhaps to a large part via the web and everything. But the world has become much more heterogeneous, and this philosophy of finding the best tool for the job is much more commonplace now than it just was a while ago. And now, like, companies are more often just looking for, like, what is the best language to implement this particular thing, or what can give me the competitive advantage over some other company that is doing a similar thing, or how can I make my developers happy, and and these kinds of things, they influence the decisions these days as well. And I think, yeah, a combination of all these features has perhaps like made Haskell transition from something that was mostly academic to something that is very much on both sides. I mean, one of the things that I'm enjoying very much about Haskell is that it is still a research language while also being a successful industry language. And there aren't that many languages where that is the case. And I think this is actually not always easy, because like the different parties have different goals, but it is also attractive somehow, because like if you're an industry developer, you get very much recent research, or if there is a new solution for something, you get that into an industry strength compiler in a very short amount of time. But also vice versa, as a researcher, is a very attractive language to work in, because you have a chance of seeing the results of your research being used in industry products, and again within a relatively short amount of time. So yeah, that works.
That's great, and it's amazing. I mean, you've been through all of the major milestones of the language. I guess that feels great now, especially that you're sticking to it.
Yeah. I mean, that's. I mean, there are new languages around, and the researcher in me, I mean, I will admit, I mean, if I see languages like Idris or Agda, or I mean, there are more of these, or even PureScript to some extent, which are just implemented, like inspired by Haskell, but doing certain things differently. I'm also like tempted to look at them, and I'm obviously also looking at them. But it is hard work also on the practical side. All the stuff that has been happening on the compiler, with the optimizations, with the runtime system. Actually, Haskell has a relatively mature ecosystem these days. It has a really good optimizing compiler that does very clever things. It's and all the libraries that are out there. It's difficult to reproduce this. I mean, like to some extent, it took a long time, but there is also something to show for it. And it's like these newer languages, they still need some time in order to catch up on those respects, or they have to interoperate with Haskell or other languages anyway. So yeah, I'm certainly not going to say that I'm going to stay with Haskell forever if something better comes along. But so far, it's very clearly sort of the sweet spot between a language that is intellectually challenging and interesting and nice, just fun to program in, but also useful.
Right. And talking about other languages, how does Haskell combine with other programming languages?
So Haskell in itself comes with a foreign function interface that allows it to directly interface with C, and C is still a language that is sort of very much sort of at the basis of nearly everything, right? I mean, basically most operating systems are still essentially written in C. So that means nearly any serious programming languages has some way to interface with C itself. So just by having like a good interface with C libraries, you can basically interface indirectly to nearly any other programming language as well. And now the memory model and the memory system of Haskell and C are very different from each other. With Haskell being a language that has like a powerful type system, you often have deeply structured data types with many different shapes, and you have this lazy evaluation which has an effect on the memory layout, and you have a garbage collection, and it's all automatically managed for you. And opposed to that is C, which is very bare bones, and you have control over everything. You typically have relatively simple layout of data structures. But the good thing is you need this marshalling code in order to like pass data between the two worlds. But you can use Haskell in order to write that, and there are good libraries for that, and you can benefit of all the abstraction functionalities and the type system strength of Haskell to make this this sensitive translation, where if you make a single mistake, things really go wrong because you get segmentation faults or whatnot. To make that rock solid, and to make sure that you're not not making mistakes in those parts essentially, and so that is relatively simple, and that's been a huge success. I mean, so Haskell has been in particular gaining lots of libraries just by binding to other languages libraries that in particular C libraries that are already out there. But on a slightly different level, I mean, these days often systems are not even just like linked to each other anymore, but they have far more loose coupling. So you exchange data via a JSON or other like data formats, and you basically just run different processes that communicate with each other via network protocols or something like that. And Haskell is also, I would say, comparatively good at anything that has to do with compilers. That also used to be a joke in the early days of Haskell. That basically the only thing that Haskell is good for is writing its own compiler, because it, the Haskell compiler, the major Haskell compiler GHC, has always, or nearly from the beginning, been written in Haskell, and for a long time initially was the largest Haskell project. But sort of the other side of the story is that Haskell is really good in anything that resembles language processing. So in parsing, type checking, code generation, serialization, all these things are things that are nicely expressible in the Haskell language, and there are very powerful tools and very powerful libraries around. So if you have anything in any other strange data format, like if it's a common data format, then you obviously have existing libraries. If it's CSV or JSON or TOML or Markdown or whatnot, or HTML, then obviously you have just out-of-the-box libraries. But even if it's a weird data format that is being used to exchange information somewhere, you can very quickly write something that interfaces with that and interoperates with other languages in that sense. And perhaps a slightly more recent thing is also that there are variants of the Haskell compiler that can compile to JavaScript and to WebAssembly. That the WebAssembly is still a little bit experimental, but to JavaScript is reasonably, I should probably say, it's also still a little bit experimental, but it is reasonably solid, and it is being used in some industry projects as well. And that opens up yet another whole new world. So even if you wanted to use Haskell as a front-end language, you could. I mean, so it's not, I would say, it's not the core thing that Haskell is being used for. And then there are these inspired languages like PureScript and Elm that are Haskell dialects that are directly compiling to JavaScript and are a little bit simpler. But if you want full Haskell and use it as a full stack language, you can essentially do this as well using GHCJS, which compiles to JavaScript. And one big advantage is obviously, again, that you can share all the data types, and between front end and back end, and that everything is compatible, and there is no way that you could somehow make mistakes there.
Oh, that's
so
very
yeah,
interesting.
interoperability in general is rather good.
That's great. Let's talk a bit about the community, and then we have quite a few questions from the audience, so I will just go through those. Okay. So Haskell community, we also have one question from the audience that they want to use Haskell in their company, but they're afraid that the community is too small. So let's try to touch a bit about on this. How easy is basically for someone to get started and to get the needed support from the community during the work?
Yeah, I mean, so Haskell is a small community. I mean, Haskell, I would say, still qualifies as an exotic language, even though it is no longer as exotic as it was before. It still has a relatively small community, but it is growing from year to year. I mean, I certainly know a time. I don't exactly when that point was where I could go to a Haskell event, and I had the feeling that I knew everyone, and then suddenly I have the feeling I hardly know anyone anymore. So and it's not because everybody left, but it's because there are so many new people all the time. Also similar, actually, like with applications to our company, like people who are applying to Well-Typed. I mean, there used to be a time when nearly everybody who was applying to work at Well-Typed, I had heard of them before, and I was like, I could basically say that if I haven't heard of them before, and then they're probably not very good. But these days, I often get amazing applications to look at from people that I have really literally never heard of before. So it is definitely a growing community. The worry that the community may be too small to commit to it is one that like I hear often and I see often, and it is certainly valid to be worried about this. But it is to some extent also coming from the fact that I think often perhaps managers are prone to perhaps underestimate their own staff. I mean, there is a habit in certain circles, I don't want to generalize, to see developers as single programming language person. So somebody is either a Python developer or a JavaScript developer or a C developer, but never all of them. And there are actually surprisingly many people, like perhaps even like in companies that don't look like it, that do look at other programming languages in their free time. And they would like nothing more than to like suddenly hear the manager say, "Oh, we could use Haskell for a project," or even like doesn't have to be Haskell, or even like we could use Scala for a project, or we could use F# for a project. And so I mean, if like, so the first thing basically is like, if you're worried about finding Haskell developers, perhaps you already have them. So but also there are many other people who are like, who are basically just applying to other positions because they feel like it goes both ways, right? Because they feel like the companies are never looking for Haskell. So I'm not going to say I'm looking for a Haskell job. It's actually only relatively recently, and only if you're flexible with location as a developer, that you can reasonably do that. You can really go and say, I'm looking for a Haskell job. You probably get lots of people who want you. But even then, you may not find something directly where you're living. You have to be open to sort of the modern remote working. So I guess to a large extent, you can find people, and it goes both ways. And if sort of companies are bolder to advertise Haskell as an option, then developers are also bolder to say, yeah, this is actually something that I'm interested in and that I want to do. And the one thing that can be difficult is, of course, if you say, all the developers on my team have to have 10 years of production Haskell experience. And I think there it's very important to have some that have production Haskell experience, because like one of the things why Haskell projects often fail, I mean, I don't want to say that they fail more often than other programming languages, not at all, but I mean, they fail as other projects are also failing. And one of the reasons they fail is that there's nobody in a team that has ever been developing a larger piece of Haskell software, and then they don't like sort of have experience on agreeing on proper programming practices, and perhaps they are using too complicated features without being aware of the cost attached to them, and so on and so forth. So, but I think that the key is to combine these things, right? To basically to look for one or two senior developers who bring in the experience, and then to not be afraid to like either just like convert developers that you already have in your company and let them learn a new programming language, or to just like literally just pick up people that are leaving university and are interested in the language but perhaps don't have that much active experience with it. But if you build such a mixed team, I think you're in my experience, you're not in a lot of trouble, and you can easily build this and grow it from there, and find Haskell developers.
And when it comes to documentation, forums, that part of the community, how easy is it? For example, you say someone more experienced in different languages, not necessarily Haskell. How easy is it for people to pick it up, or I don't know, connect with someone in case they get stuck? Just get an answer on a question, essentially.
So, I mean, obviously, I don't have the newcomer's perspective on the Haskell community anymore. And as I said, it's become much, much larger. But my feeling is that certainly it used to in the past, and I still think it is ultimately a really, really friendly community. I mean, most people in the Haskell community, if they like see new people joining in, they're going to be happy because they like to see the language growing. They like to see new people getting exposed to it, and they're eager to help, and they're eager to answer questions, and often also very, very patient. Perhaps the only thing you have to be a little bit careful of that is that sometimes some people are a little bit too enthusiastic, in the sense that they have just learned the language themselves. They are very eager to see newcomers, and they give perhaps overly intimidating answers to questions, because it's just something that seems to be something that happens in Haskell, that like lots of people are very interested in programming language theory, or become very interested in type systems and programming language theory through Haskell by being exposed to it, and then they're so enthusiastic about it that like when somebody comes in and says like, how do I parse a CSV file, then they come like, oh yeah, you have to use lenses and like this type level feature and that type level feature, when the easy answer is just that there is a library for that, and you just call that function, and then you're done with it. So but you just have to basically, I mean, this is all well intended, obviously, and friendly, but you sometimes have to filter out this sort of enthusiasm a little bit, and if you're feeling intimidated by something that you're seeing in a blog post, it's not necessarily the only way to do things, right? So it's perhaps just somebody who said, oh, yeah, I figured this out and I want to talk about this. So but yeah, I think you can easily get answers. There are lots of places on the internet where you can find help. I mean, so there's like still a very large Haskell channel on Libera Chat, like an IRC channel, where like people hang out and help beginners. Then there are communities on Slack, and there is a Haskell discourse, and there is a Discord as well. And it's actually a little bit fragmented these days, but it also means that basically whatever tool you're using, you don't necessarily even have to switch. You can find people there, and you can ask questions to them. And a very good idea is also, certainly when traveling becomes easier again, is to go to some community event, to a community conference, to something. There are conferences like the Haskell Exchange or Haskell Love, which are developer-focused conferences, and there are big like sort of community events like Zurich Hack in Zurich just next month, where people come together and are just developing Haskell projects together, and are talking about Haskell, also give some courses and so on and so forth. And I think that's a very good way to get to know lots of people, to also talk to companies, to other companies, their experiences, and also to gain more experience with it.
There's a related question to this, maybe just a quick sum up, what is the easiest way for one to start interacting with the community? Are all of these channels and resources listed somewhere for people to check?
Yeah, so I mean, no, that's a good point. So I mean, relatively recently, Haskell has gained a body that's called the Haskell Foundation. So that started last year. And it's specifically like addressing the problem that like makes it a little bit easier to organize the whole community, and to highlight where you can go. And if you go to the Haskell Foundation website, haskell.foundation, or you go to the haskell.org website, these are, I think, the two best entry points for if you're interested in sort of getting access to the community. And they have pointers to where you find other forums where you can talk to other Haskellers, or how you can also get involved in the community actively yourself.
Okay, and the same person who said they want to influence their VP to start using Haskell, but they're concerned about the size of the community. The question is essentially, how do I sell Haskell to my boss? So, just briefly, any advice if you have? What are some tips for people who want to explain to their managers why Haskell is a good thing?
I mean, if I had the universal solution of how to sell Haskell, then life would be even easier than it is. I mean, I would say, as a Haskell consultant these days, the situation is rather nice. We have lots of clients and lots of inquiries and lots of work, but it's always interesting how diverse the stories are, like of how, like we are also talking to our clients, like how did it start? How did you start using Haskell? Why did you start using Haskell? And it's not always, like, it's not so easy to find the common thread. And I also must openly admit that I've been having lots of failures of trying to sell Haskell to companies. I mean, I've also had success stories, but I've also been like having talks with people and trying to convince them. It's not that I'm always succeeding, but one thing that does seem to often succeed is to carve out something small, and to find something small and reasonably difficult, right? That is also perceived as difficult within the company, and to just write a prototype in a couple of days by one person or by two persons, perhaps even in your free time. I don't want to suggest that you should be like spending lots of stuff in your free time, but this is something that I've seen happening, right? I mean, essentially, sort of something that was a long-standing difficult corner where people were saying, oh yeah, at some point we have to do this, is really ugly, but nobody dares touch it. And somebody went away, came back after a couple of days and say, well, this is not a finished product, but this is something that actually works, and I can show it to you right now. Oh yeah, and by the way, I've written it in Haskell. And that seems to be reasonably successful, right? I mean, as an entry point of just getting the foot in the door and saying, okay, so now that we have this and it's already useful to some extent, perhaps we can like invest a little bit of money to see whether we cannot turn this into some sort of like actually viable product. And of course, there's a danger then that managers will say, oh, of course, ultimately it will have to be rewritten in a proper language. I mean, that is a story that you hear. But perhaps not even be too worried about this. Just say yes, and go work on evolving the Haskell until it is good enough so that nobody wants to replace it anymore, or nobody feels like they can replace it anymore. I mean, it's like rewriting software is costly, and if the prototype eventually ends up doing nearly everything that you want it to do, there's hardly going to be a manager that will say just like, but we have to rewrite it anyway. I mean, it's you're going to, yeah.
Great. There's one question for me that I really quickly want to answer, and then we can wrap up. So what communities like Adeva can do to bring Haskell closer to engineers? I want to push this question back to all of you in the audience. You should have my email if you're registered for this event. If not, you will probably receive an email after the event is live. Published on YouTube. So just email me back if you have any ideas, if you're part of the Haskell community or you want to get involved with the language. What are some things that we can do to, make your lives easier? Events like this are the idea we had that can help us bring Haskell closer. But whatever else you can think of, I would be happy to hear from all of you. Great. So, Andres, what do you want to, share with everyone for like a wrap up for this event? We have around 3 minutes. After that, we'll get kicked off. So,
well, perhaps one thing that we haven't really been diving a lot into is that Haskell is really, it's no longer an academic language, but it is really at its core a community-driven open source language that lives and thrives with its contributors, and I would just like to encourage all of you who might be interested to take a look and see also how you can perhaps like do something to help the community. I mean, and it's very easy to get into Haskell, in particular now with the Haskell Foundation that is really facilitating sort of these efforts and streamlining a lot of processes. And you can very easily like write your own library or make an improvement to a library, or write your own tool or make an improvement to a tool, or even work on the compiler itself. All these things are very open, very accessible, and that's a huge part of the success of Haskell that it has so far, that there are so many people now that are contributing to it and making it better every day. And even though there are always weaknesses, there's clearly a forward momentum visible, and I really like that. And I would like to encourage you all to to join the community and see for yourself, essentially, not just sit on the outside and observe.
That's great, and it's the best way to end this event. Thank you again so much for being my guest today.
Thank you very much.
Yeah, thanks to everyone who attended. Keep an eye on our YouTube channel. This will go live, will go on YouTube in the next days, and you can rewatch it or revisit some of the points we talked about. And I'll see you all next month. Cheers.
Thank you very much. Bye.